Hello everyone and welcome to today's webinar from 3D Printing Industry, the authority on additive manufacturing. I'm Hayley Everett, a technology journalist at 3D Printing Industry, and I'll be your host for today's event, which is focused on 3D printing and education, addressing the additive manufacturing skills gap. And we have a fantastic panel of speakers lined up for you today. I'd also like to remind our audience that nominations are still open for this year's 3D Printing Industry Awards. So if you haven't already cast your nominations, then you have until the 28th of August to have your say on who is leading the industry right now. So without further ado, I will introduce our panel. And if they can please turn on their cameras and microphones and join me on the stage.
Hello.
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 Let's start with some introductions. Eureka, would you like to introduce yourself and the EWF?
Yeah, of course. Thank you, Hayley. So good afternoon or good morning, depending where you are. My name is Eureka Assunção. So I work at EWF in an industrial association with a very particular focus on training and education of professionals. Just a bit of background. So EWF actually stands for the European Welding Federation. We did started with welding 30 years ago and creating and deploying the first qualification system recognized at the international level. Initially focused on welding, then it moved from welding to joining technologies, to cutting, and more recently to additive manufacturing. So, and thank you very much for the invitation, and we'll be providing a bit more information about what we are doing in additive manufacturing.
Fantastic. And we also have Fabian Alefeld, Additive Minds Manager Consulting at EOS North America. So Fabian, can you introduce yourself and EOS?
Yeah, sure. Welcome everybody, and thanks for having me. My name is Fabian Alefeld, as Hayley mentioned. I'm part of a company called EOS. EOS is the leading provider of industrial additive manufacturing equipment, material, and services. So we produce industrial 3D printers, so additive manufacturing systems. And we've been in the business for 30 years. Hans Lange, our founder, started the company in 1989. And we've been in the additive manufacturing journey ever since. We focus on powder bed technologies for metal and polymer materials. And me specifically, I run the consulting and educational services for the North American organization. We call this team Additive Minds. And what we do on a daily basis is a super fun job, which is enhancing the minds of engineers, managers, and other people that want to enter additive manufacturing in various ways. And I'm super excited to be here today to talk about the super important topic of education.
Fantastic. So once again, thank you both for joining me for this discussion. And I think there's no secret that the 3D printing industry has long wrestled with issues around employee skills gaps, long-term workforce development, and so on. And improving additive manufacturing education is seen by many as a key pillar in addressing some of these challenges. And I think it's worth here mentioning for the benefit of our audience that additive manufacturing and 3D printing will be used as interchangeable terms throughout this discussion, just to avoid any confusion. So I guess to start things off and to dive right in, Eureka, perhaps you can talk us through some of the types of additive manufacturing training that are available.
Yeah, thank you, Hayley. Yeah, of course. So when we talk about training and education for additive manufacturing, it needs to cover all different types of levels and all different types of training and education programs. Mentioning, for instance, different levels, like going from the operator to the engineer, covering in the middle, of course, managers and designers, but also looking at training in professional training, but also in higher education at university level. All of that become really relevant when you're talking about types of training and required types of training for additive manufacturing. Another important part, which is very much in the backbone of what EWF has been working on and worked on in the past for welding, there needs to be a mix between what we call practical training, skills development, competence development, and knowledge that supports those skills and those competences. So it's not a question about learning just behind the computer, but it's also a question of learning by doing and playing with the machines and using the machines. So this type, when we're talking about AEM, all this diversity needs to be taken into consideration, not only like I mentioned, looking at professional training for professionals that are already in the market, but also looking at university training and looking at professionals that will be in the market. And this is very much key aspect, especially in new technologies like additive manufacturing.
And Fabian, do you have anything to add to that? And perhaps you can give us an idea of why training and education is so important for the AM industry in particular.
Yeah, sure. So, if we think of additive manufacturing as an industry, it is still a quite new industry. It's still an emerging and innovative technology. And we need to treat additive manufacturing as such, right? If we look at other technologies, whether if it's artificial intelligence or Industry 4.0 technologies from sensorics, all the way into new learning concepts with augmented reality, organizations usually approach these types of new technologies through education and or through new hires. The challenge with additive manufacturing is that there is a so-called war for talent as of right now, which means there's very limited amount of talent out in the market that companies can acquire. And therefore, companies need to focus more on educating existing employees and their workforce. And to me, there's two main success factors to that. Number one is, yes, the core is engineers. We need to educate engineers for additive manufacturing. And from my experience, engineers love that. They want to do that, right? When people tell us engineers don't really understand additive manufacturing, I don't think so. I think engineers understand additive manufacturing, but oftentimes they're not given the tools or the freedom to learn more about this new technology. But also we need to educate other functions of an organization. We need to talk about supply chain management, procurement. Management itself needs to understand the opportunities, but also the limitations of additive manufacturing. And when it comes to types of learning, I think, Eureka, you said it perfectly. To me, there's two different main sections. There is proactive learning, which is going through educational programs. And then there's active learning on the job, which is usually a try and error learning where I just try something out, it fails, and I learn from that experience. And then the best case, we combine these two into more complex educational and ramp-up programs.
Fantastic. And I just want to, before we move on, I'd just like to remind our audience, we are taking questions throughout the event. So if there is something that you'd like to ask our panel, you can use the Q&A function and we will try and answer as many as we can. And after that great introduction from you both, I guess we should go on to look at the current skills gaps in the 3D printing industry. And Eureka, this is a good opportunity for you to tell us about EWF's European roadmap for additive manufacturing, perhaps some of the key findings that you found there.
Yeah, thank you, Hayley. So just once again, a bit of background. So a couple of years ago, the European Commission, in order to support exactly what Fabian described, this lack of talent around additive manufacturing, talent that is critical to implement new technologies, and AM is definitely one of the new technologies that is here to stay. The European Commission supported or provided a bid for developing and identifying the need in developing a roadmap for skills identification and deployment at the European level. So we've been lucky enough to be awarded that project. So we've been running it now for 2 years. There's 2 more years to go. And the idea there was to, like you mentioned, Hayley, so to identify what is missing, and what will be missing in terms of the talent for additive manufacturing. By doing so, develop a roadmap. And we actually started this roadmap some years ago. So we went as an industrial association led by industry, we were asked to look at additive manufacturing in terms of what was the most urgent skills and the most urgent area in additive manufacturing that needed to be developed in terms of skills development, and there was a big lack of professionals also. And when we did the survey a couple of years ago, I say a couple of years, but probably 4 or 5 years ago, metal additive manufacturing was the top priority. So that was something that everyone said, forget about the rest of the materials. We need professionals that are able to work with additive manufacturing, with metal additive manufacturing. And as part of this roadmap exercise that we are doing, we were able to identify that this trend keeps changing. Picking up what Fabian mentioned, it's a new technology. It's a process that is keep evolving, new materials, new processes, and that also we were able to identify that change. So we started with a big focus in metals. It's still the top material, but now we are seeing other materials like polymers, ceramics getting into the manufacturing environment as a production technology, not just as a prototyping technology. So as part of that roadmap, we were able to identify this a bit, I won't say this change of trend, but at least understanding that there's, first of all, AM requirements in terms of skills change quite constantly, quickly, but also that new materials are appearing in a manufacturing environment. So that was one of the first things we were able to identify. We are looking at what's coming afterwards in terms of what new materials, new process will be trendy in the couple of years, and based on the feedback we are getting from industry, based on surveys, market search also. And we are also able to identify that the types of qualifications are also changing a bit. Fabian mentioned a bit on looking at supply chain managers, procurement managers, but also there's still some commonalities regardless if you're working in metals, if you're working in polymers. So we have seen requests for operators heavily specialized when you're talking about metals AM, operators a bit less specialized if you're talking polymer AM, but we are seeing those types of this type of requirements coming from industry also. And once again, and this is probably Fabian and coming from EOS, that's something that something that people need to also be aware of, which is not just about one process. So we see companies looking more and more at different AM processes and understanding that they are not competing with each other, they are complementing each other. And we've seen that by seeing companies asking, we need also engineers capable of being specialized in a specific process, but being able to identify which other processes can be used and what makes sense for that specific application and for that specific company. So we've seen that in terms of road mapping, when we did this road mapping exercise, that is still an ongoing exercise, we also saw that. So a diversity in terms of materials, a diversity in terms of processes, but also a diversity in terms of qualification profiles that are required. So like I mentioned this before, so we are looking at operators for different AM processes, powder bed fusion with laser beam, DED with arc, but also professionals that know a bit about everything, about sometimes specializing only in metals, sometimes specializing in powder bed fusion with metals and polymers. So we are seeing all these changes coming up, and we are trying to deploy something or identify a strategy with the European Commission to make sure that in the future, companies can act as a professional that Fabian mentioned are missing in the market, actually before they are missing. So we are trying to work to be able to deploy and develop the necessary skills and knowledge that when the technology that now is new, but it will not be new in 4 or 5 years' time, or is implemented in the manufacturing environment, already has professionals in the market ready to use it.
And I suppose that's one of the challenges, is because it's such a fast evolving industry with new technologies and materials all the time. When you're conducting these surveys, is it kind of a continual thing? Every time something new comes along, you then have to look at that again, and how does that kind of work from an organizational point of view?
So that's a very good question. It's a lot of hard work actually. So we run surveys. We run surveys every 2 years to keep updating in how the trends are. We also run, let's say, closed workshops. Some of them with machine manufacturers, for instance. EOS is one of them actually, but we are very proud we were able to sit down all the main machine manufacturing, powder bed fusion, laser beam, around the table discussing, okay, guys, you work in powder bed fusion. What other process do you see out there appearing, and how do you see them influencing what you do and influencing the market? So we do that almost constantly, Hayley. So we do that every couple of years, but we do workshops in the middle. We also look at patents, applications, what's coming up, to understand those trends. And apart from that, and I think it's also relevant to mention now, we're actually creating and implementing already what we call the first international additive manufacturing qualification system. And what that means is we are creating a network of training centers using the same framework, and we also collect feedback from those training centers. So we have training centers at regional level in different countries, currently already 7, and going outside of Europe already in the next couple of months. But they also provide us input. So they say, Eurico, they say AWS, look, we've done training on powder bed, we've done training on DD, but now we're getting customers and companies asking for training on binder jetting. So that also allows us to be a bit closer to the market and closer to the companies and getting that feedback also. And I think just picking up on what Fabian said, is a fast evolving technology. So what happens today will be slightly different in 1 or 2 years' time. And we need to be ready for that. And that requires a lot of work and requires listening to companies and hearing what they are saying. Another aspect we take into consideration, Hayley, and sorry for taking a bit of time on this one.
No, that's fine.
We also work with standardization bodies. So we also engage with ISO, ASTM, AWS, NatCap for aerospace accreditation systems. So we also work with them, trying to understand how those sectors and how those standardization communities and bodies, what they are doing in terms of standards development, which when we're talking about manufacturing, moving from prototyping, going to a manufacturing environment, standards are almost a backbone requirement. So they need to be in place and they are being developed, and we keep track on that. I'm actually the convener of ISO CC 261, Joint Group 74, which is personal qualification. So we keep track on that to understand, okay, this standard is being developed. Do we have the training program in place that can answer that standard that is being developed? So that's something we also do in parallel with everything else I mentioned.
Fantastic. And Fabian, perhaps you can give us a US perspective on this, and what areas do you see sort of the largest skill gaps in the sector being?
Yeah, sure. So just to connect to what Hayley said, and Eurico also what you said. So yes, the industry is evolving, and yes, the technology is continuously evolving. But sometimes organizations use that as an excuse, right? And that's something that I really want to point out. There was a very nice survey from McKinsey and the World Economic Forum about, in general, Industry 4.0 technologies. And what they found out is there is a fast mover advantage. There is no second mover advantage anymore. Why? Because organizations who invest into these technologies today have an advantage already today and significantly in the future. Why? Because it takes time to develop your talent. It takes time to develop your organization for such new technologies, and not just because there is no talent, but also because you need to grow your expertise and you need to grow your portfolio in these new emerging technologies. And that's why I always like to think of two enablement factors or two gaps that we see. One is the technology readiness, so understanding how additive manufacturing can be implemented in operations and in productions, but also in supply chain. There is, of course, it takes some time to get your first 3D printed application to market, especially the first one, right? It'll take on average 1 to 2 years to develop the process, to develop the design, get it through qualification, and so on and so forth. Now, 70% of organizations are stuck in pilot purgatory, meaning they do one project, doesn't quite work out, and then the technology isn't ready. Oftentimes the technology is ready, but the organization is not ready, right? And here, that's why we really focus on what does an organizational setup look like, and we try to understand in a very early stage, what is the impact that additive manufacturing can have on your organization, on your value chain? And that's a mindset shift, right? Sometimes companies or engineers look at one part, one application, and then they try to figure out how can we now develop this for 3D printing? Can we save cost with this part when we 3D print it? Whereas additive manufacturing can have a way larger impact, right? It can boost your innovation. It can reduce your R&D lead times. It can improve the performance of existing parts and whole part groups. Here the value is much more than just a cost reduction. It's increasing your competitive advantage, increasing your speed to market, reducing working capital in supply chain and in warehousing. So the skill gap is not only very dedicated engineering or operator functions, it's also the broader understanding of more than one person in an organization, so cross-functional teams, of the actual impact of additive manufacturing. And that's the two components that we try to teach. We try to teach, of course, engineers, how do you design for additive manufacturing? How do you develop processes, and how do you adjust laser parameters to achieve certain critical features within your parts, right? Support-free design is one of the newest innovations from many companies out there, and of course also from EOS, where you can adjust process parameters where you don't need support structures in your design anymore and in your print. The next then is qualification, teaching quality engineers how to approach the qualification process for additive manufacturing and how it's different from other conventional technologies. How do you achieve operational qualification throughout a system part, and how do you achieve performance qualification? Then on the organizational side, as I mentioned, achieving this new mindset towards additive manufacturing, and that starts also in finance, right? Having a business case for additive manufacturing is actually not that difficult. And the nice thing about additive manufacturing is it's quite scalable. If you find a business case for 100,000 parts, it can scale up, and your cost per part will not significantly change to $1 million or $2 million cost, because you can scale and multiply your blueprint. So those are the things that we focus on when it comes to education, where we see the skill gaps that's hindering organizations from implementing additive manufacturing successfully in the long term.
And with the Additive Minds program, what sort of milestones have you achieved so far? Is there anything you can talk about where you've sort of measured the success of the program?
Sure. So Additive Minds was started in 2016 out of the necessity that additive manufacturing was moving from prototyping into production. And already in 2016, we saw a huge skill gap, especially in engineers. And as I mentioned in the very beginning, back then, the only way to learn and educate yourself in additive manufacturing was try and error, which is quite expensive. Having equipment and engineers and failed builds and failed material, that can pile up to quite some significant sums over years. So it's a very expensive way of education. Now, what we did was we took the knowledge of the engineers out of EOS that had 20 to 30 years of experience back then, I guess 24 years of experience, and packaged that into educational programs that were theoretical, to really understand the physics behind additive manufacturing, why certain design freedoms and design challenges exist and how to overcome them, but also the practical aspects of additive manufacturing, so getting your hands dirty, printing parts, ripping parts off the build platform, understanding what different support structures have an impact on, what different process parameters have an impact on. And we've now grown that by now 2021 into a team of more than 100 global consultants, engineers, and instructors that do nothing but educate and work on defined projects with our customers to learn on a project, apply the knowledge that we teach onto one of their applications, and therefore combining the theoretical and the practical knowledge. And in addition, what we've done over the past 2 years, especially due to the impact of COVID and the impact that we couldn't teach face-to-face anymore, is we started the so-called Additive Minds Academy, which is an online platform for digital learning content. We have roughly 15 different programs that take from 3 weeks all the way to very extensive programs of 6 weeks, or sorry, 3 days to 6 weeks, that focus on various different functions, from design engineers to material development engineers to quality engineers. And yeah, these already today can be found on the EOS website. There's a button on the upper right that says store, where you can go through those training programs yourself.
Fantastic. And we do have a couple of questions. The first of which is, how do the skills as a 3D printing hobbyist translate to an industrial AM environment? So which one of you would like to take that one on?
I can, or do you want to go, Eureka?
No, you can go. I'll go after you. That's fine.
I think it translates quite well. You still have some gaps, of course, right? If you compare an FDM printer to, let's say, a powder bed fusion metal printer, there's many differences, but there's also similarities, right? In both, you need support structures. In both, you need to rethink the way you design products. So I think it's a very good start to educate yourself on home desktop versions of additive manufacturing systems. And it can really give you a head start to push into the industrial additive manufacturing space. There's still much more to learn, but I think the mindset change that you learn from printing parts at home is quite significant.
And Eureka, do you have anything to add to that?
Yeah, I agree with Fabian. It helps with the mindset. There's still a bit of a technical gap between, let's say, an FDM printer to have at home, and for instance, a powder bed fusion printer, even for polymers, to have in a factory. I'll give you an example. So we actually looked at that, and for instance, the training, if you want to become a user for an FDM polymer machine, less than a day. If you want to become an operator for a powder bed fusion system for metal, it can go from 1 week to 2 weeks to be completely independent to work afterwards. But the mindset is there, so that's already a big achievement. Just keep in mind there's a bit of a gap in terms of a printer at home, a 300 euro printer, and a 300,000 euro printer. So and just people need to be also a bit aware of that. And actually, Hayley, if you allow me, I'll just share a very interesting situation that we had, that we were made aware during this COVID situation. We had hospitals in Portugal getting parts that needed to be sterilized at high temperatures to be used for during the first wave, to be used as connectors into the ventilators. And the hospitals complained to us saying, listen, we are getting hundreds of parts by mail, by post. People are sending over parts that were done at home, and they send it over, they put into the sterilizing machine, and they melt it away. So people need to also to understand there's a big difference between something that is really industrial and something that we use at home. But like Fabian mentioned, the mindset is a big achievement.
And one more as well, which is kind of related to this that we've got sent through to us, is mechanical engineering or electrical engineering, or is material science better to get ahead in the AM industry? So Fabian, how about we come to you first on that one?
Sure. I think sometimes people overestimate the impact of the degree for additive manufacturing. I think if I look at all the people we've worked with, there's chemical engineers, there's industrial engineers, of course, mechanical engineers and material scientists. I think some of these functions fall more into a certain additive manufacturing function, right? Material scientists, I think when it comes to qualifying serial production parts and understanding the material structure, super important for serial additive manufacturing, especially in the restrictive industries of medical and aerospace. So here we very often work with material scientists. On the other hand, mechanical engineers, yeah, if you have an additive manufacturing understanding as a mechanical engineer, you can really have a big impact on the R&D of additive manufacturing, and you have an impact on the early stage definition of the manufacturing process. So I don't think it's an either or. I think all of these functions can give you a really good head start for the additive manufacturing industry. And the only thing I can also advise is to look at the program if you're about to get into your bachelor's or master's degree, just to see if they touch additive manufacturing, right? There's certain universities that are ahead of others. Some universities still only talk about additive manufacturing as a prototyping technology, and they call it rapid prototyping. Some others really already focus on additive manufacturing as a manufacturing technology. So that would be one of the things that I would look at when selecting a program, is how extensively do they touch base on additive manufacturing?
Yes, some great advice. And Eureka, what are your thoughts on this?
Yeah, I think that's a bit like Fabian mentioned. I think that's space for everyone. We actually did an assessment, what we call access conditions. What type of background do you need to have, or you should have, for different types of qualification that is manufacturing, from the operator to the process engineer to the materials engineer, like Fabian mentioned, and there's space for all of them. We also see, a bit like Fabian mentioned, there's a bit of a lack of harmonization how additive manufacturing is addressed, for instance, at university level. But we are working with them, and this is part of our activities, working with universities to get to a level that they can actually teach additive manufacturing, not only as a prototyping process, but as a manufacturing process. Another part here, and I think picking up on this topic also, which is people also need to be aware that additive manufacturing doesn't need only engineers. It also needs the rest, not only managers and engineers. It needs operators, it needs designers for more complex parts that probably need to be design engineers, but also for less complex parts, they can be designers, simple designers. So we are working on that. So there's space for everyone in additive manufacturing. But we also need to be aware that looking at professional training, there's a bigger gap in professional training compared with university training when it comes to additive manufacturing. And if we want to make sure that we address the lack of talent, like Fabian mentioned, we need to address both university training and professional training, and that's very important.
And I guess this leads us on quite nicely to what we were going to talk about next, is the differences between education in academia and also in a professional setting. So I guess, how about you expand upon what you were just saying, Eurico, and give us some of the differences and what's required?
Yeah, we need everything, Hayley, actually. We can't forget that when we talk about, and I mentioned this at the beginning, when we talk about the upcoming workforce, so people that are currently students, yeah, university is a good way for starting, to get that knowledge and those skills. When you talk about professionals, they are still the majority that are already working with other technologies, and for them, AM is probably a black box or some type of magic, which is not it shouldn't be considered as that as such anymore. We need to look at other types of training, and this is where professional training plays an important role. We've seen that in the welding sector for many years now. People come from universities, they have some knowledge in welding, but if they want to become welding engineers or they want to be responsible for welding in their company, that is not enough. Experience is critical, but also experience supported by well-structured qualification and training is a must-have. And we are seeing exactly the same thing in additive manufacturing. And that's why we need to address both. We need to address academia to make sure that the upcoming workforce is made already aware of what AM is, what type of role it can have in a manufacturing environment. But then we need to professional training to make sure that the ones that are already in the market, the ones that are already operating and working in companies, also become aware of additive manufacturing and are capable of implementing it. So this is very much important. And like Fabian mentioned, you can learn by doing, but it's very expensive to learn by doing. So if you could learn with professionals, with experienced professionals giving you, transferring their know-how and their experience, that's very much important. So that's why professional training plays a big role here. And I'll just add, and this is actually one of the biggest challenges, because we've seen this at the European level, but also outside, which is academia has easy access to machines. And AM machines, they are expensive machines, especially when you go to metal. Professional training schools, professional training centers, they do not have access to those machines. They need to develop collaboration with companies or with academia to be able to address that. So the gap there is really big. So we are working trying to reduce the gap by creating collaborations between companies that have machines and professional training schools that can support them in giving training, and cooperation between universities and professional training schools also to be able to access the machines. But that is very much important, and it needs to be taken into consideration.
And Fabian, do you agree with this, what Eurico is saying?
No, 100%. I think, as you said, Eurico, academia and professional education go together, and they both have a huge positive impact on the development of future talents. And yeah, what you just said, access to additive manufacturing, industrial additive manufacturing equipment is still not easy. There are, especially in the US, a bunch of universities that have industrial size equipment. We also collaborate with many of them. One to name Texas A&M as an example. We have a joint additive manufacturing certification program where we talk about all additive manufacturing technologies and we deep dive into the industrial additive manufacturing technologies of powder bed fusion. Yeah, we also, as EOS and the Additive Minds Academy team, have developed these professional education programs where you combine hands-on experience with the theoretical knowledge, as I mentioned earlier. And that, from our perspective, is always such an important step for organizations to start out, because the internal understanding and the actual understanding of additive manufacturing, it sounds so easy in the theory, but once you built your first build and it fails and you have no understanding why, that guidance of a professional who can really tell you, okay, you oriented this part towards the recoder and you had a recoder contact and that's why it crashed, or it was overheating here and there, and that's how you can eliminate that by either redesigning the part or adjusting the support structures or orientating it different in the build envelope. All of that information is super important, and the best way to learn is actually a guided try and error. Right? Having participants fail almost on purpose to enlighten them why a build failed is almost more important than just running a successful build. So that's how we try to approach it. And in the best case, we always do it on the case of a certain project, where we then actually also work on an application that has an impact on the organization, as I mentioned earlier, where we have already a positive business case identified, that so the investment that a company takes into a part is not for nothing, but that it already has a payout and a return of investment in the midterm.
And I guess we could talk about some of the challenges of actually delivering this 3D printing education and training. And Fabian, perhaps you can, expand on perhaps what challenges you've seen at EOS in terms of actually delivering the training.
Yeah, I mean, one of the main challenges is people don't know what they don't know, right? And sometimes we talk to engineers who either have tried to step into additive manufacturing 5 years, 6 years ago, and it didn't work out. As I mentioned, they're still stuck in pilot purgatory. And then there's already this mindset where additive manufacturing is only for prototyping, or it can only produce low density parts, whereas in reality we can achieve forging densities. We can achieve densities of 99.99x%, right? So the technology has evolved, and that's where these previous failed projects can actually have a quite significant negative impact on a current project, right? And another challenge that I mentioned earlier that I think is very crucial is to really identify the value add of additive manufacturing to a company. Just printing a part to print it doesn't add value. Looking for a pure cost reduction part also oftentimes doesn't add value. Looking for a part that has a positive impact on the bottom line by adding value to an application, by reducing assembly steps, by consolidating parts, by improving the performance through complex geometries, or reducing weight by improving the weight to strength ratio through topology optimized parts, all the way into concepts such as digital inventories, where we can move away from last time buys and minimum order quantities by holding inventory in stock. So having these organizational transformation ideas in the back of our mind is super crucial, and one of the challenges why some companies fails, because they don't treat it like an innovative, high impact technology.
And Eureka, do you see a similar thing from your perspective?
Yeah, I'll see, and I'll pick up one Fabian's last comment on the added value. Another part we found it quite challenging, and it still is, the diversity and the added value of the different processes. It's quite different. So we looked at that. So it's how to give training regarding, considering that you have diversity of already existing AM processes. More will follow probably, and their added value and their business case and their reason for usage or for using that specific process is quite different. So this for us was actually a challenge. We actually structured the training program that we have based on specialization per process, because if you look at powder bed fusion, you have a reason, and you will find your reason, the specific added value why you're using powder bed fusion. But if you look at DED, for instance, with arc, with laser beam, the business model, the reason for using it is completely different. And because we work across a different board in terms of additive manufacturing technologies, we found it very challenging to accommodate that. And actually, one of the first meetings we had with industry, we asked, okay, listen, what type, with companies, we asked, okay, what type of engineer would like to have for additive manufacturing? And they said, we want an engineer that knows about all the processes and can implement all the processes. And we said, you don't want an engineer, you want Superman, because the diversity is so big and that's difficult to accommodate. So what we're trying to do is, listen, we need engineers that are aware of the existing processes, know enough about it to understand where they fit, but then you need engineers, in this case, I'm just talking about engineers that are really specialized in one specific process. And this was one of the biggest challenges we found, was the fact that IM is not just one process anymore, it's a variety of processes, and all of them have their rightful place in manufacturing.
We have another question from one of our audience, and they're asking, do you see 3D printing service bureaus as a possible step into gaining some exposure into AM? So that kind of links in quite nicely with what we're talking about. Fabian, perhaps I'll come to you on that.
Yeah, I think 3D service bureaus or contract manufacturers are, a very beneficial part of the additive manufacturing ecosystem. They oftentimes have different technologies. They understand quite well which technology makes sense for certain applications. I would still advise to combine that with some education, and even with some consulting services, because sometimes the selection of a part is quite crucial, and companies are disappointed when they receive a part that doesn't meet their expectations. That may be because just the part isn't great for additive manufacturing. That may be because a different technology was selected in the 3D printing service bureau, and there was a mismatch in communication. So yes, I think they're a crucial part. I think they're very good to start out in a small series production, combined with education and combined with a good understanding of the limitations and the possibilities of each and every technology.
And
Eureka, what are your thoughts on service bureaus?
Yeah, I think what Fabian said is 100% correct. So service bureaus currently have a very important role in the supply chain for additive manufacturing. Adding to what Fabian said, I'll just add a topic, which is service bureaus is a good way of getting to understand which technologies exist, what can you start to do, but sometimes there's a gap there, which is what you can do and how good quality can you achieve. And that's something that we normally see that companies need to internally work on if they decide to go an additive manufacturing route. And we suffer this a lot, which is companies saying, oh, I just buy the printer and I just print. And that's what the service bureaus do mainly. But keep in mind there's a lot of work behind it to assure that the quality of the part is according to your requirements. And that's something that the service bureaus already internally manage, and the customers sometimes don't see that happening. They just know that the part is up to their requirements. But when it's a company, they need to understand that if I do additive, I need to make sure that additive is done in the right way and that I get the quality that I require for my part, and what type of procedure I need to have in place to achieve that quality.
Fantastic. And we also have another question. Who have you seen start taking advantage of the online AM training? So Fabian, perhaps I'll come to you on that.
Yeah, I mean, whoever asked me referred to the Additive Minds Academy training. I can post a link to the training here in the chat. I think that may also clarify some of the questions, but I can't talk about all the companies that went through it because that's confidential information. But I think one of the most taken trainings is so-called part screening and selection. Part screening and selection teaches the participants how to select your first additive manufacturing application, what I mentioned earlier, how to assess the value add of additive manufacturing. It teaches the so-called economic value add. So how do I calculate cost per part for 3D printing? How do I assess the economic value add? Here we talk about, for example, part complexity. So the surface to volume ratio of a part. We talk about different materials that are printable in additive manufacturing. And we talk about how to also assess the value add of, for example, lightweighting or any structural optimizations like that. Then there's the technical fit that we teach, which is a part printable? Should it be printed, right? If it's a block, probably not. If it's a complex part that we assessed in the economic value add, maybe yes. And what do you do when something is in between? So it helps you to kind of cluster your applications and find that first application, that first part that has an economic and a technological value added benefit. So that's something that we've seen many organizations go through and that we also include into actual programs that we run with our customers. So what we do on a weekly basis is we put together these custom programs for organizations that consist of e-learnings, that consist of so-called application sprints, where we take apart, we identify the solution space, and then we reiterate on a daily basis, redesign, print overnight, and therefore we combine these theoretical and in-person trainings. And from an industry perspective, yeah, I think as Eureka will probably confirm, additive manufacturing is pushing into new industries. You of course see space and aerospace and medical heavily pulling and increasing the amount of additive manufacturing applications, but also the automotive industry, the lifestyle industry, from helmets to protective equipment, and also some other applications. And of course, industry as in general, such as gas turbines, they're all pulling into additive manufacturing, and we see all of these industries and organizations benefiting from these online trainings, at least from a first step to explore some of the knowledge and the missing information that I talked about, the don't know what you don't know, which is actually quite dangerous.
Fantastic. And Eureka, I'll come to you on this next one. What type of printer do you think is the best way to understand the additive manufacturing sector?
It's a tricky one because it's what I said. So we need to keep in mind, if you want to have the mindset, just to get the mindset of what 3D printing is, an FDM to have at home makes perfect sense. Regarding the rest, then the processes are really different. We need to keep in mind that we combine into this sentence of additive manufacturing or 3D printing, but they are very different. The application, for instance, of powder bed fusion with laser beam for metals is completely different when you talk about DED with us. It has nothing to do one and the other. So we need to be people need to be aware that when you talk about additive manufacturing, the range of process already available is quite big, and their application and their usage and their characteristics are quite different, and people need to understand that. Then the rest is about if you're just someone curious, pick the one you prefer or the one you enjoy the most. If you're a company, then you really need to analyze. And I'll pick up on what Fabian mentioned about this online and I think he mentioned something that just going back a bit, Hayley, if you allow me. The online bit is, and we did pilot testings on this. The online bit is very good to get, let's say, first approach and secondary approach, understanding how can I do, what AM is, how can I use it, where it makes sense, when it doesn't. But then there are things that you really need to get your hands on to be able to understand a bit better. And we've seen that, especially from for operators training. You will not trust an operator that never saw a machine before or never been in touch with this online training. But even from an engineer perspective, this possibility of exchanging ideas and discussing about ideas face to face with the machine, with parts in your hand, is becoming more and more needed. And we actually piloted that, and we're able to identify what can be done online and what actually needs to be done in a factory, on the job, or at least with some engineers around you to be able to capture that knowledge. Going back to the first question, if you're a company, you need to evaluate and understand where it makes sense. If you're just someone that wants to get into it, an FDM machine is a good way to start, and a cheap one probably.
And have either of you experienced any challenges getting people to take online AM training as opposed to in person? Or Fabian, what have you seen?
I think it changed so much in the past year, right? We used to struggle with positioning online trainings because people really only wanted in-person trainings, and then of course we all know that COVID-19 happened and changed the way we live our lives. So now there's more acceptance to online trainings, and Eureka said it. It's a great first way to start. I think it's a cheap way to start out, right? Our trainings are also, some are even free, some are in a $30 range or a few $100, so it's quite cheap. And you really get a good baseline for additive manufacturing. And this baseline then allows you to invest a bit more into in-person programs and especially applied projects where we then apply the knowledge and the expertise onto specific applications. So it's a really good way to start out. And the one thing we've realized is those blended learning formats, online, in person, hands-on, that's the best way to learn.
Eureka, do you agree with this? A mixture of both is the best way?
Yeah, I agree with Fabian, and we didn't discuss this previously, but we actually saw you need this mix of what Fabian mentioned, this blended learning, online and presential. And we actually had some situations at the engineer level that because of COVID, they went 100% online through a period of time, and they requested that some of the topics need to be done presential, because they miss the discussions that sometimes do online you don't are able to develop as much in terms of discussion. They miss touching the parts, they miss being close to the machine. So we actually had this request, and this is why I think what Fabian mentioned makes perfect sense. Blended is the best way forward, and this is actually what we are looking at into understanding what people are comfortable with in terms of being online in front of the computer, and then what you really need to get people together and being more presential.
And with there being such a broad case of applications within the AM sector, how can a company guarantee quality and certification from parts created via 3D printing? It's another question from our audience. Fabian, I'll come to you on that. Yeah,
sure. I mean, all I can recommend is work with experts, right? Work with teams such as ours that have helped many companies to push parts into serial production. We have quality engineers that have an educational approach, so we don't want to, qualify your parts. We want to teach you how to qualify a part. So that's what I can advise you. Don't try to do everything by yourself. Rely on the experts. Try to find experts who teach, who don't do the job for you. That's sometimes a bit dangerous, right? If you solely rely on companies that don't educate but just consult and hand over some predefined documents, then you're kind of stuck in you're codependent on those organizations. So look for that, work with the experts, educate your team, look broadly, and the last thing that I can advise you is be open to failing from time to time, be open to get stuck from time to time, but know there's people out there who can help you. And if you look at the industry, there's parts flying in airspace. There's medical implants implanted into bodies. It works, and it will happen. Yeah. Just go the journey and be aware that there will be some stepping stones ahead.
Eureka, what are your thoughts on this? Do you agree?
Yeah, qualification certification is actually needed for most of industries, and AM is not different. When we did the surveys in terms of what the engineers need to do, qualification, certification, facility assessment was considered as top priorities, and that's why it's included in the training program for engineers. I will just add a bit more what Fabian mentioned, which is there are standards already out there, which standards are not are guidelines mainly, and there are already standards for aerospace, for medical, for other sectors being developed, standards from ISO, STM, from AWS, V20, NetCap for aerospace already has a checklist for accrediting or qualifying powder bed fusion systems for aerospace sector. So there's already some documents out there, some standards that can definitely support. And then what Fabian said makes perfect sense. If you learn, if you get trained, and you do it, then you can always get support, and getting support from people that already went through it. It's very important. But if you learn it by doing it, you also understand when something goes wrong, what happened, and that's very important.
And a very easy way to learn, actually, I just thought of this, is I recently started a podcast, and as the US, we started a podcast called Additive Snack. And here we interview industry experts on these exact topics. So one episode is with Mohsen Saifi, the director of ASTM, or the additive manufacturing director of ASTM. And he talks about all the standards that exist around qualification, but also design. So yeah, also recommend to tune into that podcast. It's free education and quite nice to hear what other people have to say.
Fantastic. And I suppose if we look just towards the end of the webinar, I've just looked at the clock and we've been chatting so much, we're nearly out of time. But looking at sort of current opportunities that are available, Fabian, perhaps you can let us know currently or anything that's upcoming from Additive Minds that people could perhaps take advantage of.
Sure. We continuously update whatever we're working on our social media channels. So there's the Additive Minds Academy LinkedIn page where we continuously update with new programs. We're working on many university partnerships that will launch additive manufacturing programs soon. And yeah, we're continuously updating new trainings in our store as well as new episodes of our podcast bi-weekly. So yeah, tune into those channels and you'll be up to date continuously.
Fantastic. And Eureka, what about from the EWF? What have you got in place at the moment?
Yeah, Hayley, so we've been developing the International Additive Manufacturing Qualification System. So we are in the, let's say, the rollout phase now. We already have training centers in 6 countries. It will be 7 in September. And by the looks of it, it will be 10 countries at the end of the year. These are covering professional training schools, universities, research centers, which also play a very important role. So we'll be rolling out those ones across the different, creating this network of training centers that use a harmonized and international framework aligned with standards to develop and to deploy their training program. So this is something we are doing. We are, like I said, we are, if I'm not mistaken, we already have just close to 30 training centers in the process of being authorized or in the process of being authorized. So it will be, 2021 is an interesting year. I think 2022 will be a non-stop one. So, and also a bit of information, we start with European countries, and by the end of the year, we already will be in countries outside of Europe. So that's very exciting for us. It means that people that want to get trained in additive manufacturing will have probably a training center, being a university, being a research center, or being a professional training school, close to their doorstep, so where they can actually do the online bit, but also the presential bit.
Okay, great. Well, thank you both so much for your insights today. I'm afraid that is all we have time for. I've seen a few more questions have just come in, but if you stick around, we've got a networking session straight after this, so hopefully you'll be able to get your questions answered. To do that, you'll be directed back to the networking area once this webinar finishes, and then you can click on the tables and chat to the other attendees of the webinar and also our speakers. So thank you once again to Fabian and Eureka for joining me. It's been fantastic to have you on and sharing your insights. And just one final reminder before we go that nominations are still open for this year's 3D Printing Industry Awards. You have until the 28th of August to cast your nomination, so make sure that you do that. And on that note, thank you both very much for joining me, and I'll see you all in the networking session.
Thanks, everybody. Thanks for having us.
Take care.
Thank you.